Hello friends, in this video we see definition of differential equation and its types. Before it we will see what is meant by dependent variable and independent variable. Suppose we have y is equal to f of x, then the variable y for its values depends on variable x. So in this situation y is dependent variable and x is independent variable. So we can find derivative of y with respect to x and we denote it by dy by dx. That is nothing but the rate of change of y with respect to variable x. Similarly, we can find second order derivative d2y by dx square, which is nothing but derivative of dy by dx with respect to x means the rate of change of dy by dx with respect to variable x. Suppose we have y is equal to f of x comma t, means variable y depends on two variables x and t. In this case y is dependent variable and there are two independent variables which are x and t. So we can find derivative of y with respect to x as well as derivative of y with respect to t, and derivative of y with respect to x is denoted by dou y by dou x, or it is also called as dou y by dou x. That is nothing but rate of change of y with respect to variable x. Similarly, dou y by dou t is rate of change of y with respect to variable t. Suppose y depends on more than two variables, means suppose y is equal to f of x1, x2, x3 up to xn. N can be anything, any natural number. And here we are taking n is greater or equal 3. See, in this situation, variable y depends on variables x1, x2, x3 up to xn. So y is dependent variable and x1, x2, x3 up to xn are independent variables. So for any k from 1, 2, 3 up to n, we can find derivative of y with respect to variable xk. That is nothing but rate of change of y with respect to variable xk. Now we have here seen that dependent variable may depend on single independent variable or more independent variables. Now let's see the definition of differential equation. A mathematical equation that involves derivatives is called a differential equation. And we have seen that to find derivative, dependent variable may depend on single independent variable or more independent variables, and depending upon the number of independent variables involved in a differential equation, we characterize or differentiate differential equation into two types: ordinary differential equation and partial differential equation. Let's see what is ordinary differential equation. An ordinary differential equation is a differential equation that involves derivatives with respect to a single independent variable. For example, dy by dx equal to cos x, d2y by dx square minus 3 into dy by dx plus 2y is equal to 0. Y is equal to x into dy by dx plus under root 1 plus square of dy by dx. We can see that all these are the examples of ordinary differential equations, since there is only one independent variable, that is x. Now let's see what is partial differential equation. A partial differential equation is a differential equation that involves derivatives with respect to two or more independent variables. Let's see the examples. Y square into dou z by dou x plus xy into dou z by dou y is equal to x into z. Here you can note that z is dependent variable and there are two independent variables x and y. Another example, dou square z by dou x square plus dou square z by dou y square is equal to 0. This is partial differential equation in which z is dependent variable and two independent variables x and y. Another example, dou u by dou t is equal to k into dou square u by dou x square. Here u is dependent variable and there are two independent variables t and x. Here k is constant. Another example, dou square u by dou t square is equal to k into dabba square u by dabba x square plus dabba square u by dabba y square. Here u is dependent variable and there are three independent variables t, x and y. Here k is constant. Okay. In this video, we have seen definition of differential equation and types of differential equation, which are ordinary differential equation and partial differential equation. Thank you.